In this video, we will explain more about shear force and bending moment. Example 1. Let's look at the first example. There is a vertical force acting at point C. What will be the shear force and bending moment at points A, B, C, D, and E? First, we need to find the reaction forces S1 and S2. It is easy. By taking moment about E, we have S1 equal to 8 Newton. That means S2 will be 12 Newton. Then, for point A, we cut the beam into two parts and consider only the left part. In order to ensure the left part is in vertical equilibrium, the shear force must be 8 Newton. Then, by taking moment about point A, the bending moment about A will be 3.2 Newton-meter. Similarly, for point B, using the same procedure, the shear force is 8 Newton. The bending moment will be 6.4 Newton-meter. For point C, the steps are slightly different. First, consider the location just to the left of point C. That is, the load at C is not included. To ensure the left part is in equilibrium, the shear force should be 8 Newton. By taking moment about C, the bending moment will be 9.6 Newton-meter. Then, we try to include the load at C as well. In order to ensure the left part is in equilibrium, the shear force should be 12 Newton, pointing upward. That can be treated as negative 12 Newton if we take downward being positive. By taking moment about C, the bending moment is still 9.6 Newton-meter. For point D, the shear force is still 12 Newton, pointing upward. The bending moment will be 4.8 Newton-meter. Finally, for point E, the shear force and bending moment are both 0, because the left part is already equilibrium. If we plot the shear force of each point into a graph, we can see there is a sudden change of shear force at the point C. When we plot the bending moment, we can see that the maximum value is also at point C. Example 2. Here is another example. When the applied load is not vertical, what should be the shear force and bending moment at point A? The calculation steps are the same. The first step is to find the reaction forces. When taking moment about point O, we can find the reaction force, S2. Then, by considering vertical and horizontal equilibrium equations, we know that there is a vertical reaction force and a horizontal reaction force at point O. Then, let's look at the left part of point A. What should be the shear forces at point A? There are vertical and horizontal internal forces at A. The vertical force is the shear force, which is 7.07 Newton, while horizontal force is called axial force, which can also be called a tension force or a compressive force, depending on its direction. We will learn more about it later. Again, by taking moment about A, it is easy to get the bending moment at point A. It is around 3.54 Newton-meter.